What other tool you have been using?
JUnit testing.
JUnit testing tool. What else? GitHub, right? You better store your code or your documents somewhere. I mean, nowadays, if you just store your code on your computer, you are at peril, okay? You are waiting for disaster to strike. That's like the other day, I was going to my faculty meeting, I accidentally put my coffee next to my computer, and my colleague came over and knocked the coffee on my keyboard, and then my computer basically goes to the storage afterward. That cup of coffee cost me $699 to buy a new computer. All right? So if you only have however, I didn't lose any data because all my data is actually Google Drive. Then I basically just get this computer, log in, set up my Google Drive. I'm doing all the work I need to do just like before. If you only store your code and your data on your computer, you are waiting for things to happen. Okay? What else? We have IDEs. We have JUnit test. We have we have GitHub. What else? What else you have been using?
Chrome, or browser.
Browser, yeah, definitely you need that. I mean, all your documentation tools you typically use. Besides that, at this moment, I mean, later on you will later on you will be using project management tools, but at this stage, you don't really need it. A Google Sheet, a Google Doc, I mean, a Word document, and will be sufficient. Don't overcomplicate your work. Okay. At this stage, if you have all these tools, you can do my project, do almost all the project. In fact, you are actually able to do most of the engineering work in industry. Okay? So once you add that project management tool, you have a complete suite of tools. You can start running your own cheap software shop. On cheap. Actually, you don't have to pay for any of those. Right? With a computer, you can start earning some money. Okay? That is our industry. You may say it's still primitive, very primitive, right? Oh, we've gone a long way. I mean, with this primitive set of tools. IDE getting really powerful. Internet is great, and so we are actually getting better and better. But you don't really need to overcomplicate your tool. I mean, certainly you need the metrics for your stage as well. Once you do inspection, you actually have faults, right? Errors you detected from a checklist that not match and things like that, which will help you, right? So essentially, in classical analysis, challenging classical analysis, and your object current analysis is that right now in object current analysis, from very beginning, we introduce the concept of classes and objects. Then our handover from our analysis, high-level design into detailed design, is very straightforward. Basically, we just ship our object class definition to the next stage. We are continuing on, right? However, in classical analysis, there's nothing like that. You're doing your DFD, then basically a data flow graph, then you have to turn that into some kind of code structure. There are no straightforward way of mapping, like in object oriented design, basically object definition, class definition into your implementation. There are no connection like that, right? That is exactly why object-oriented approach got introduced, right? So early on, you would like to be able to keep all the information together, so you can moving through the process, you keep the same information always. But in classical approach, you basically have to go from the data flow diagram into your C program structures. That is a jump. That is when a lot of mistake happens. However, if you use class diagram, you're easily transition into your implementation. In fact, there are many tools basically can generate your generate your code structures from your class diagram. Easy, because that's a very simple transition. So the key, a big change in terms of advantage of object-oriented approach over classical approach is the concept of class. And the concept of a class appear really early in the process in object-oriented analysis, then transition all the way into implementation. However, in classical analysis, you don't have such a mapping division. You basically have to map those program structure yourself. Okay. So that's basically what we have for the classical approach. So essentially, the core in this chapter we talk about is if you are going to do C programming or basic Python programming with no complicated structure, basically sequential plus control flow code, yeah, you basically are doing classical approach. How to do it? I mean, your friend is data flow graph. Basically, how data flows through your system. Okay? How data flows through your system. Why is that important? Because your computer is a data processor. You are a data processor. You better identify the data into your system and how they flow through. If you can identify all the data in your original specification, you have enumerated all the routes they go through your system, then you got it covered. Okay? Then the advantage of object-oriented approach would be you associate your data with operation, so it's more clearer, right? More hierarchical, easier to compose, right? So make your programming a little bit more simple. However, object-oriented approach is a syntactic sugar to make your life easier, but it's not fundamental. Not fundamental. Okay? Fundamental is really the classical computer. Basically, classical model is essentially your Neumann computer model. Data in, got a process, result out. The Neumann model basically is instruction in, result out. Same idea, same approach, right? So that is why it's called classical approach. It classically representing our fundamental computing structure. Okay? Anything you can do with object-oriented approach, you can do the same with your C programming. You may have done a wonderful website using JavaScript. You may say, yeah, you cannot do that in C. No, you can't. Just take you much longer time, right? You draw these buttons and all these things all by yourself, right? So it's doable, right? Just that your efficiency is not there. All these things with new framework, a new programming language, new this thing, a new that thing, and all these things make our work better, make our things we do better, but they are not fundamental. Fundamental is your computer is data in, got processed, result out. That won't change. That won't change. Okay? Even for quantum computer, I mean for biological computer, I mean the computational model is probably going to be the same. Just that the computational complexity may not be the same. For instance, a quantum computer, you can put a lot of information into it at the same time. Biological computer like us, right? We can put a lot of information in, a lot of information parallel out at the same time, right? We're thinking about many different things at the same time, essentially, controlling many different things, right? Our computer, I mean, with the current model, harder to do so. Okay? The computation model will change, but general model, I think, will remain for quite some time. Because that's how human being is built, how our society actually functions. Data in, data out. Produce new generation of information. Okay, all right, so that'll be it for our lecture on classical approach. Now let's look at the quiz today. This is the time for you to use your IDE. Okay, so this is, still we are feeding on a trace, right? We're keep doing things around the tray. So this one is actually on the largest value, largest value in each tree rows. So this is also a problem, and I basically steal it from another website, right?
By tree row, do you mean level?
Let's see. I think that we have that. We have an explanation. Much better to look at the specification. Which one? We're looking at 515. All right, this one is actually not that easy. Okay. So, on each level, you are required to find the largest value in each level. And print out the largest value on each level, right? So for instance, level 1, the root only going to be 1, 132 is going to be 1, 539 is going to be 9. Okay? So my recommendation is you go set up this tree and call the method. The method will return basically random stuff. Then your output is expected to be this. Then you fail. Then you see then you start adding your methods, and until this test pass. Okay? Then run some other tests to make sure that your implementation is robust. Like you can see a skeleton of the Java program right here. Make it a little bit more familiar for you guys.